Welcome back, everybody. I hope you've been enjoying the workshops that you attended today. I am super excited to be part of this workshop and learn with you guys the chemistry of lava lamp. So I'll have Sarah introduce herself and lead the workshop.
Okay, thank you so much. Can everyone hear me? Could someone give me a thumbs up? Awesome. So my name is Sarah, and today I'm going to be guiding you through a workshop called The Chemistry of Lava Lamps. And basically, we're going to use some scientific concepts to try and understand how these work. And so throughout the presentation, I'm going to be asking you to either maybe answer some questions or give me a thumbs up. Feel free to actually give me a thumbs up this way, or you can use the Zoom emojis. If you have any questions, feel free to just go ahead and raise your hand or send it in the chat, and I'll try and answer your question right away. So why don't we go ahead and get started? So I'm assuming most of you have seen a lava lamp before. Maybe you've seen it in person or in a movie or in a TV show or something like that. But if you're not super familiar with them, I have an image up on the screen here. They're awesome because you basically just have these glow-in-the-dark globs of goo that somehow move up and down and stay one color while the background is a completely different color. And there's actually a lot of science behind this. So today we're going to be setting up a simple experiment to try and understand some of these concepts. And specifically, we're going to be thinking about things like density, solubility, and some simple reactions. So I'm going to just share a brief materials list right here so you know what you'll need today. So with you, you should have some sort of glass or plastic container. You know, an old soda bottle works well, just a plain glass like this. This is what I'll be using. Ideally, you just want it to be see-through so you can actually make observations and see the experiment that you're doing. So make sure you have something like this. The other thing that you'll need is some water. I have some set aside in a container here. Tap water, bottled water, anything works. You probably only need about a cup or so, not very much. And then you'll need some vegetable oil or mineral oil. Again, you will not need this much. I have a lot, but just even a small cup will be fine. The good thing about this experiment is you can kind of just throw it all together and it just magically works. And then you'll need a little bit of food coloring. I'm using red, but you can use any color. And then ideally you have some Alka-Seltzer tablets to use. So they look like this, and they come in a container that looks like this. If you don't have Alka-Seltzer tablets, aspirin can also work, but that effect that we'll see is a little bit less pronounced with the aspirin. So ideally, if you can use Alka-Seltzer tablets, that would be great. So I'll give you a minute just to make sure that you have all your materials. And if a couple of you could give me a thumbs up when you're ready, we can actually start the experiment. Awesome, I'm seeing a couple. Great, I'll give it another couple seconds and then we can get started. Okay, so I'm gonna just first verbally walk us through the experiment. You don't have to do anything yet. So we're gonna do it all together, but I'm just gonna give you a heads up on what we're doing. So the first thing you'll do is just fill your container, whatever container you're using, about a quarter of the way full with water. Then we're gonna add our food coloring. Then we're gonna add our oil, and then we'll add the Alka-Seltzer tablet. But again, you don't have to do any of this yet. We're gonna walk through it. So is everybody ready to go? All right, so I'm gonna stop screen sharing so you can see my screen and do everything alongside me. So now you should just see my video here. Okay, so go ahead and get your glass ready and take whatever water you have and just maybe fill your container, whatever it is, about a quarter of the way full with water. Okay. A quarter, a third, it doesn't really matter. You can see I've done this much right here. And when everyone has done that, if you could give me a thumbs up, that would be great. All right, so on to the next step. What we're gonna do now is you're gonna take your food coloring and just add a couple drops into that glass of water. You've probably done this before at some point in your life, so we're not at the exciting part yet. And you probably just need 1 or 2 or 3 drops, and that will do the trick. This is what mine looks like. And when you've done that, give me a thumbs up so we don't leave anyone behind. Okay, so in this next step, I want you to pay attention to your glass. So as chemists or scientists or anyone who's really curious about this will do, try and pay attention to what's going on in your glass and see if you can make any observations and notice what's happening. So what I'm going to do is I'm going to take my vegetable oil and I'm going to pour it in so my glass is about halfway full. And when you do this, observe what's happening. Think about, okay, are the liquids mixing together? Where is the red color going? And try and observe what's happening. Okay, so this is what mine looks like. So would anyone be willing to share what they just observed? Are you seeing the liquids mixed together? Are they separating out? Where is the red going? So what you should see here is that our oil has separated out on the top of the glass, as Helena said, and our water's at the bottom. And the water is the only one that's colored red. The oil has no food coloring in it at all. Does anyone have any guess for why this is happening or what concepts this has to do with? So I'm going to go ahead and share my screen again so we can think about this a little bit more. But what's going on is when you have two liquids, these liquids can actually weigh different amounts. And this is a concept called density or mass per unit volume. So if you have something that's much heavier, it's going to go straight to the bottom because it weighs a lot. And if you have something that's a lot lighter, it's going to go towards the top. So as Helena said, our oil is less dense than our water. So our oil is floating to the top and our water is going to the bottom and they're separating out. This also has to do with a concept called solubility, which is simply a material's ability to dissolve into something else. So in this case, we're seeing that our oil and water are not soluble in each other at all. They're not dissolving in each other at all. And I think we've already pointed this out a little bit, but this is a good point to think about, okay, what is food coloring actually more soluble in? And as Helena pointed out, the food coloring seems to be going into the bottom water layer. And so that means that our food coloring is more soluble in our water than it is in our oil. Are there any questions about these concepts or how any of this works here? There's a lot of different concepts that can impact something's solubility in something else. So I actually don't know for sure why the food coloring is more soluble in the water. It probably has to do with the density of it. It also could have something to do with the polarity, which is a concept we're not talking about as much today. But if the food coloring is made up of similar compounds or similar substances to the water, it's going to more easily dissolve into it. So it's this idea of like dissolves like. So water is very polar, where oil is very non-polar. So that could be another influence, but that's a little bit more complicated. Okay, so this is personally my favorite part because it's the part where the really cool stuff happens. So what you're gonna do now is you're gonna take your Alka-Seltzer tablet, and if you can, break it up because it will make this step a little bit easier. So I'm just gonna kind of snap it in half. You know, you can put in half a tablet, you could even go up to a full tablet. And when you drop it in here, I want you to, again, really carefully look at your glass and try and think about what's happening. So make those observations. Notice, is the water going anywhere? Is the oil going anywhere? Where is the red coloring going? Or if you don't have red coloring, see what else is going on in the glass. And then we'll talk about it afterward. So go ahead and take some Alka-Seltzer, and I'm gonna put a bunch in just so you guys can see it, and drop it into your glass. So this is what mine looks like. And as you can see, it kind of actually looks like a lava lamp. We're getting that lava lamp effect where we have all these colored bubbles going up and then coming back down again. And you probably can't hear this from my end, but maybe listen to your glass and see if you can hear anything. All right, mine is still going. Would anyone be able to share their observations on what's happening in their glass or their bottle after they added the Alka-Seltzer tablet? I can also share as well. So hopefully what you guys saw is that a bunch of colored bubbles were forming in this layer, going up here, and then coming back down again. Is that what people saw? And did anyone hear anything? So I heard a lot of fizzling noises, a lot of bubbling. It sounded almost like a really mini cool explosion. So does anyone have any guess of what happened here when we put that Alka-Seltzer tablet in? What caused the bubbling? What caused the noise? So what we actually just witnessed, and hopefully you can see my screen now that I'm sharing the PowerPoint again, what we actually just witnessed is that Alka-Seltzer tablet sinks to the bottom, right? Because it's pretty heavy, but it actually can react with the water. So some sort of chemical reaction is going on in there. And that's what's causing the bubbles. And so in that reaction, we're actually forming tiny pockets of gas. And what do gases do? Does anyone know? Are they light or are they heavy? They're light. So what's going to happen is the gas bubbles are immediately going to go up. And so they're bringing some of that water with them, and they're bringing some of that red food coloring with them all the way up to the top. And once the gases escape out the top of the glass, the red food coloring in the water, as we already talked about, isn't soluble in the oil. So it does not want to stay there. It's going to go straight back down. And that's what causes all this bubbling and this really cool reaction to happen. Are there any follow-up questions about what we just observed and the concepts we just talked about? So everything has a limit of solubility, of course. So there could be a point, I guess I don't know the limit of solubility of an Alka-Seltzer tablet, but there could be a point where you wouldn't be able to dissolve all of it in the water and have it react. But I think it would probably be pretty hard to reach that point and take quite a while. We're using a pretty significant amount of water, but that is a science experiment you could try, right? You could just keep adding Alka-Seltzer tablets and see what happens, safely, of course. But I imagine it would take quite a while because the water isn't necessarily going away in that reaction. As we saw, it's coming back down. And so it's continuously regenerating and probably can then continuously react with our Alka-Seltzer tablet. So one thing you may be thinking is, all right, this isn't a real lava lamp, obviously, of course, right? So one key difference, I think, is that after a while, this just stops bubbling. Lava lamps, they just go on forever. They bubble up and down. So we have to ask ourselves, okay, what is the difference? What's going on in an actual lava lamp that's causing this difference so it can continuously go on? Does anyone have any ideas from the top of their head? So I actually had to do a little bit of research to figure this one out, but there's two things going on. One, our lava lamps, they're connected to an electrical source, right? So they have a steady stream of power that's going to help keep this going over and over again. But the main difference is that the bubbles going up and down isn't caused by a chemical reaction over and over again. It's actually caused by a temperature dependence. So what do I mean by that? Well, the lava lamp is actually going to be operating at two different temperatures. There's going to be one part of the lava lamp that's colder and one part of the lava lamp that's warmer. Okay. So does anyone have any ideas of why that matters or what that causes? Another question to help think about this is, do hot things rise or do they fall? Think about hot air balloons. What's happening is at the bottom of this lava lamp, what they're doing is they're heating it out a little bit more, causing the bubbles to go up as they warm up. And once they get to the top, they're cooling the top. And once those bubbles are cooler, they're going to go back down. So the lava lamps still involve these concepts of solubility and density to explain having bubbles of certain liquids being separated from each other. But the reason why they go up and down is a little bit different from the experiment that we did today. But hopefully what you saw today is that we can use this experiment to think about lava lamps and how they work and some of the concepts that are at play. And if you want to think about this a little bit more, there's a lot of things that you can do. So the cool part about this experiment is it's really fast. It's really easy to set up. And so I have some ideas if you maybe want to try this again later today or at the end of our time here today. There's a couple things you could do. So you could add the oil and the water first and then add the food coloring and observe what happens. Or try adding the oil first before the water. We just talked about temperature dependence being important in actual lava lamps. So what you could try and do is maybe use warmer water or colder water in this experiment and see if it makes a difference. You could try using things other than Alka-Seltzer tablets like salt, or try using aspirin instead of Alka-Seltzer. So there's a lot of different variables at play, right? We have our water, we have our oil, our food coloring, and our Alka-Seltzer tablets. So you can vary each of those things and see if there's a difference in the experiment and use that information to draw conclusions about what's going on here. And so this actually brings me to the end of our experiment today. So I'm happy to take any more questions about any of these concepts, about the experiment. And if there are no questions, I hope that you guys will continue to maybe try another version of this experiment or play around with it and see what more you can learn. Thank you guys for your time and for doing this science experiment with me. And I hope it was enjoyable and fun for you all. What do I do in grad school? So I am a chemist, of course, and I study how to make plastics more efficiently and also how to make them more recyclable and more environmentally friendly. So that's what I'm mainly focusing on now. And I'm also taking a lot of classes and I'm helping to teach organic chemistry right now too. So a lot of different things at once. So it was a little bit of an accident, to be entirely honest. When I was in college, I decided to take chemistry as my science electives, and I really liked it. So I decided to take another chemistry course. And one of my teachers convinced me to do essentially lab experiments, sort of like this, but a little bit different. And I just loved playing around with materials in front of me and being able to see the science happen real time. And I liked asking questions and trying to figure out answers to them. And so I just kept taking some of those lab classes, kept exploring those things, and it ultimately led me to just keep going because I liked it so much. So here I am now.